Alright, so in the previous slide, we saw examples for computation of the greatest common divisor, but we saw that they require computation of all the divisors of numbers that we're considering, which becomes tedious for larger numbers. So here we see yet an alternative and simpler way of finding the greatest common divisor in terms of the prime factorization of the underlying numbers. So we see here that again we have these two numbers a and b, each of which can be expressed as a product of prime numbers according to the fundamental theorem of arithmetic. And we saw various examples earlier where we expressed numbers in terms of prime numbers as a product of prime factors, where the multiplicity of factors is expressed as integers a1, a2 and a sub n for the number a, and the multiplicity of the factors is expressed as b1, b2 and b sub n for the second number b. Okay, and we choose these prime numbers in an ascending order, and we don't allow them to be equal to each other. So all of the prime numbers are in ascending order and distinct from each other. And the powers of these prime numbers come from numbers, which are greater than 0 and less than or equal to n, okay, depending upon the prime numbers we have. Alright, so once we have these expansions of a and b, we can easily pick out the factors which are common between the two. For example, if you look at the powers of p1, the smaller of the two numbers a1 and b1 will constitute the common factors between a and b. Okay, so we find the minimum of these two powers to include it in the greatest common divisor. Then we go to the next prime number and look at its power in both the factorization of a and the factorization of b. So we find the minimum of a2 and b2, and we keep on going until we exhaust all the prime numbers in the factorization. Alright, so now we will look at an example where we use this method to find the greatest common divisor.